Hello and welcome to Sudoku. Here is a little killer arrow Sudoku puzzle by the famous constructor DiMono. Well, DiMono is famous if you follow Cracking the Cryptic. Many of DiMono's puzzles have appeared on that channel. And I thought I'd have a look at this one. And to be honest, I already attempted it and almost solved it. It just broke in the end because, well, that's what I do. And so I assume you're familiar with little killer Sudoku rules and arrow rules. And if you wish, you can have a look. I've written the rules here. So, how do you begin this? Well, what I thought was, let's have a look at those two mini diagonals. What are the digits on those? And the interesting part of it is that every time you take those cells into account, you actually count those ones. Let's have a look. This way. On this 45 diagonal, you take this cell, but this one is the sum of those, and then you take this one. This one is the sum of those cells. This one, well, that's this cell, to be sure. This one, and this one, which is the sum of those cells, and this one. And then, what else will we get? Let's have a look at this diagonal. Well, obviously we get this cell, this one. This cell is the sum of those. We also get those cells. And then you see that we almost get all of those two regions, except that we are missing these. And these numbers add up to those numbers. So let's just take into account this mini diagonal, which corresponds to those cells and this one. And the result is that the sum of those three diagonals is the sum of all those digits plus the outliers here. So what is this sum? This sum is 98. That's the sum of those three numbers. And those two boxes add up to 90. Therefore, if we remove those boxes, we get a sum of 8. Those 6 cells add up to 8. And those cells have a combined minimum of 3, 1 plus 2, same here. Those have a minimum of 1, and this very minimum is 8. So those cells must contain the absolute theoretical minimum. And those ones are a 1-2 pair, and so are those cells, 1-2 pair. So that's a very nice start. Now, where do we look? That's a reasonable question, and obviously I've forgotten where I should look next. but this 26 draws my attention. Let's have a similar count. We take this cell, and this cell, and this one is the sum of those cells, and this one is the sum of the other cells. And now all this orange sum is 26. But let's highlight the outliers again. Let's highlight them in green, and here let's highlight the missing digits in blue. And then again, let's do some mathematics. Orange plus blue is 45. Orange plus green is 26. Therefore, let's subtract the equations and we get B minus G is 19. Which means that this is this plus 19. Oh, sorry. Yes, oh, no, that's okay. So this has a minimum. Let's think. The orange, so B, blue is G green plus 19. Now let's think about the orange cells. They have a minimum of 21. And just the blue cells have a maximum of 24. 7 plus 8 plus 9. So maximum of 24. So this is a maximum of 5. So those two digits have a maximum of 5. And something interesting is that this one can't be a 1. So it has a minimum of 2, this one a minimum of 1. So it's a minimum of 3. So green is either 3, 4, or 5. And blue, correspondingly, is either 22, 23, or 24. Well, and I think that's nice. What more can we have? These cells along the arrows have a minimum of 15. So those two digits have a minimum of 15 and a maximum of 18. So there's not much leeway here. Well, that's probably not all that there is to it. Oh, I think I remember there was something about those. Oh yes, there was something very special. What was that? I had come to a very strong conclusion about those cells. What was that? oh yes, it was about 1 being excluded from all those cells. So the minimum value for the combined sum of those 3 arrows is 2 plus 3 plus 4 plus 5 plus 6 plus 7. And this is actually 3 times 9. You have 9 here, and 9 there. So you can't have less than 27 for those 6 cells, and it's the maximum when those digits are 9. So they are 9, and all these digits are those ones in some order, and the remaining digits must be 1, 8, and 9. So 9 goes there, 1 goes here, 8 goes here. That is really, really fun. So this now has to be a 6 to fulfill this 16 sum. And those now don't include a 1, so they must be 4 and 2 in this order. Now, we know that this is not a 1. So the minimum here for the green becomes 4. And we know that blue must be either 23 or 24, which means there are a 9 and an 8 here, and a 6 or a 7, which remains to be determined. What else do we see? So 2 is around here. And actually, we almost have our 45. We need another 17 with this, and that, which is not yet completely resolved, I think. But then, 9 must be there, but it won't be on the arrow, so this is a 9. We must have a 9 in one of those cells, but this one can't be a 9, because this plus this is at most 5, so this is a 9. And then we get a 9 somewhere here, and it won't be on the arrow, so there's a 9 here. And we say that the minimum sum of those 5 yellow cells was 15, the sum of all digits from 1 to 5, 15, but then this has a maximum of 7 and this has a maximum of 8, so the maximum is also 15, so this is a 7, this is an 8. So we have 15 here and 30 here, so this is 6 or 7. And the missing digit is here. So this is 6 or 8, this is 6, 7 or 8. And there is a 7 among those cells. Now that those add up to 4 or 5, they are 2 or 3. And correspondingly, 2 and 3 will make this a 6 and this an 8. 2 and 2 will make this a 7 and this a this 8 makes this a 6. So that's a 7, that's an 8. Let's remove the colors. So we say 9, 6, no, yes, 6. And what was it again? This one must be 8, and this one is 7. So now this is 22, and we get 2's on the outskirts. And this has multiple combinations, I think. We can have 7 be 2 plus 5, and then 8 be 1, 3, 4, or 7 could be 3 plus 4, and 8 could be 1, 2, and 5, in which case 2 goes there, and I think that's it. There's a 2 in one of those cells. Oh, there's a 9 here, by the way. And by Sudoku, we get the last 9 of the grid here. Very nice. Now, should we have another look at this 45? We have 28 here. We need another 17 with those being between 2 and 4. So this is between 15 and 13. No, and yes. Well, that doesn't seem very helpful. But here, on this row, this has a minimum of 3 plus 5, 8, and 8 is also the maximum value here. Now, this has a minimum of 1 plus 6, 7, and maximum of 8. So 1 must be on this arrow, and it must be here. This is 7 or 8, and accordingly this will be 6 or 7. And we need an 8 here, and 6 or 7 there. Now we know a lot about this. We already have 36. We need 9 with this, this, and that. And there is some degree of freedom. It could be 1 and 2 and 6, or it could be 1 and 1 and 7. So nothing is quite certain at this point. But, oh, here, there's a 2 on this arrow, and it is paired with a 7, making this an 8, this a 7, this a 6. And now we know that those 2 digits are 1 and 2 in some order. So there's still some work to be done. And there we need somewhere 4 plus 5, somewhere 3 plus 6. And I don't know how to decide for the moment. But Sudoku tells me this is a 6, and this is a 7, and we need 3, 4, 5 in those cells. We need an 8 here. One, 3, 4, 5. Oh, there's a 7 here. There's a 7 in one of those 2 cells. This 26 is fulfilled. And this 37, will be fulfilled once we put a 1 and a 2 here. Let's check. 24, 34. It works. So we just need to remember, that this and this are different. So this and this are equal. So those are both 1s or both 2s. Well, 1 wouldn't go here because we would need a 6. 1 will be on this 8. Two is in one of those. doesn't seem to be very helpful. So, is it about the 45 clue? Or is there some more Sudoku logic? Yes, Sudoku logic gives me an 8 here, a 7 there, a 2 here, a 7 there, and another 2, 3, 4, 5 now. And the last 7, no, the last 7 is here. There's an 8 here, a 6 there, 3, 4, 5. I just hope I won't need some kind of coloring. Oh, what did I do? I repeated a 6. That's, oh, this is bad. No, this 7 was correct. But those 3, 4, 5 were not. Actually, this is a 6. This is 3, 4, or 5. This is as well. So this one is 6, 5, or 4, correspondingly. And I don't know what's here. But this 45 now, oh, sorry, this 2 gives a 2 here. There's a 1 around here. This is 3, 4, or 5. And then let's have a look at this diagonal. We already have 26, 37. So this plus that is 8. What are the options? 3 and 5, 4 and 4, 5 and 3, and that's it. Well, that is anticlimactic, I think. Let's check. 11, 21, 30, what? 21, 34. Oh, no, sorry. I miscalculated. 15, that's 34. So those should add up to 11. So the only way is with 6 here and 5 there. That's the maximum value. Okay, now I understand this one much better. And this 5 makes those 1 and 2, and with this 2, that's 1 and 2, 2 and 1 here. That's a 1, that's a 2. And we can check that, yes, each 2 is paired with its friend, the 1. Now those must be 3 and 4. There's a 1 here, 3 or 4. And then 8 goes there. 3 goes here, 4 goes here. This is not a 4. This one is a 6, that's a 1, that's a 5, which resolves the 3, 5 pair on the top. That's, oh, everything falls into place. We get a 5 here, a 4 there. We get a 6 here and a 3 there. That's a 5. This is a 3, this is a 5. and then that's a 4, a 3 and 5 here, and now remaining digits are those, and we get a 6, we get a 5 here, and a 3 there, and it all seems to work. Now I'm going to Logic Masters Deutschland, where DiMono published this on the 1st of April, and it was no joke, it was not a hoax, which we would associate with this very day. So I'm typing the solution code, and I'm trying not to make mistakes as I do on Grand Prix, and this is correct. So the difficulty, I would say it would be 3+, and it's absolutely gorgeous. Not unusual ideas, really not unusual ideas, but very well put together. I really like this puzzle. Thanks for watching this video, and see you soon on Sudoku.